Hello, we are from Group 20. In this video, we'd like to present our assignment about sensible heat effect while focusing on Henri, Regnault, and Gustav Kirchhoff. Our contribution. This is our teammate. History and definition. Early 18th century, German chemist George Ernst Stahl proposed the phlogiston theory, which stated that substance called phlogiston was released during burning. However, this idea was later disapproved when scientists found metal gain weight after burning. 1789, French scientist Antoine Laurent Lavoisier replaced phlogiston theory with oxygen theory. He explained combustion and respiration as reaction with oxygen. According to him, heat is tasteless, odorless, weightless, and invisible fluid that he labeled as calorific fluid. In 1798, Benjamin Thomson discovered that boring can able to produce endless heat and suggested that mechanical work could be converted into heat, thus challenging the caloric theory. Later, in 1849, James Perkot Joule proved through his experiment that work can be converted into heat, and thus a fluid relationship exists between the two. This led to the concept of 1 joule equal to 10.241 calories of heat. In 1850, Rudolf Clausius introduced the first law of thermodynamics. He stated that energy is conserved. It can change form, but it cannot be created or destroyed. Next is definition of sensible heat. Sensible heat is the heat that can be felt or measured with thermometer. It causes the change in temperature because adding energy makes the air molecule move faster, thus increasing the temperature.
Moving on to fun facts about personal life. Henri Victor Regnault was born in Aachen, Germany, but he grew up in poverty after losing both parents when he was just a child. He also worked as a textile apprentice before he managed to earn a scholarship to study in Paris. Regnault had a son who became a famous painter, but had died in the Franco-Prussian War. He didn't really trust mathematical theories that weren't backed by experiments. He withdrew from public life until his death. Gustav Kirchhoff was known for his calm and gentle personality. He had an accident in his early 20s that left him partially paralyzed in his legs, but that didn't stop him from teaching. Kirchhoff had a wife named Clara Richelieu, who he had 5 children together. Kirchhoff also enjoyed classical music.
Let's talk about the contribution of the scientist to thermodynamics. Henri Victor Regnault, as known as Regnault, has 2 main contributions. The first one is the specific heat capacity, which is Cp. The following figures shows the apparatus used by Regnault to measure the specific heat capacity of solid and gases. His method for measuring the specific heat is famous since it produced highly precise results. Regnault also did his research on the thermal expansion of gases at several conditions. As his conclusion, the coefficient of thermal expansion of an ideal gas alpha is the same for all gases at constant temperature and pressure. Kirchhoff's laws in thermal radiation states that at thermostatic equilibrium, the emissivity of an object or surface is equal to its absorbance at any given wavelength and temperature. Formula below is the formula used when the Cp is independent of temperature, while figure 6 shows that the schematic depiction of Kirchhoff's law. Besides, his law of thermochemistry states that the change in the heat of reaction with temperature is equal to the difference in the heat capacities of products and reactants.
Application and example. Henri Regnault. Henri Regnault measured the specific heat of gases and liquids. His work helped engineers calculate the heat needed to raise a fluid temperature. Example, heating 1 kg of water from 20 degrees Celsius to 80 degrees Celsius. We need to apply all the information into the equation Q equals to mass times specific heat times temperature change. Kirchhoff's law states that a body ability to emit heat equals its ability to absorb it. This principle is used in solar collectors and furnaces. For example, black metal plates absorb sunlight and convert it into sensible heat, showing how absorption raises temperature.
Here is another example of calculation about sensible heat. So to conclude, sensible heat helps us understand how energy changes cause temperature differences. Henri Regnault improved how we measure heat, and Gustav Kirchhoff explained how heat and energy are connected. Their work really shaped the thermodynamics we use in chemical engineering today. This is the list of our references, and that's all from us. Thank you.